Hey everyone, welcome to a new video. My name's Jason. Thanks for checking out the channel where we talk about solar panels, batteries, power stations, and more. And today we are looking at a brand new power station that just hit the market. This is the LemiPower 1500. Now this has a ton of features and a really good build quality. For example, this does have lithium iron phosphate batteries inside, so you're gonna get a lot of life cycles and there's no fire risk. And it has things like UPS functionality, smart app connectivity, tons of USB ports. It has DC output on the front. You have your AC inverter on the back, wireless charging on the top, LED lights. I could go on, and I'll talk about all these features a little bit later in the video, but first off, I have a lot of really good impressions about this power station. Now, the whole purpose of this video is to give you guys the facts about this power station by actually testing it and seeing how it performs against its advertised capacities and specifications. Now, I've already tested this completely. I already have all the information documented, and that's what this video is all about. So we're gonna be flying through the performance on this to let you guys know if it's something that you're gonna wanna purchase or if it's going to be a hard pass. Now, the LemiPower 1500 has 1500 watt hours of capacity and a 1500 watt pure sine wave inverter. Now, it is priced at an MSRP of $29.99, meaning it comes in at around $2 a watt hour at its normal price. Now, by purchasing it on Kickstarter, you do have a little risk versus reward. For example, the risk is that it's an unfinished product. There might be a few little bugs, but you actually get a reward of a cheaper price. The Kickstarter price on this comes in around $15.99, so a little over $1 per watt hour. And the early bird price, meaning if you're one of the first 50 that backs in on this project, you can pick it up for around $13.99, so $1,400, so a little less than $1 per watt hour. So if you are interested in a power station that has lithium iron phosphate, UPS functionality, smart app connectivity, no external charging bricks, it has all the charging built in, and it can charge up with a decent amount of solar, then you may be interested in watching the rest of this video. So let's go ahead and jump into how this performed, starting with the DC output. Now, in order to connect up anything up to this power station, you'll want to turn on the DC output and the USB ports, and you can do that by pressing the buttons on the screen. Now, once they're on, you have a ton of different ways to connect up your devices. You have 4 USB-A ports, 2 of them are Quick Charge 3.0, and you have 3 USB-C ports, one being 30 watts, one being 65, and then one being 100 watts output. Now for the DC output, you have a cigarette plug in the middle with a dust cover, and then you have 2 5521 barrel connections where you can connect up all your DC appliances. Now, of course, I did testing on these ports, so let's go ahead and jump into those results. Now, in order to test the DC output, I plugged in my battery load tester starting with the 12 volt socket, and to see what it was regulated at, I plugged it in with no load, and it was showing around 12.2 to 12.3 volts, and that is the same throughout the entire state of charge. So whether you're 100% or 20%, it's going to stay at 12.3 volts. Now, to test the maximum output on the 12 volt cigarette plug, I turned up my battery load tester, and then went all the way up to around 11.3 amps. And we were pulling around 145 watts on the screen. Now, there is a little bit of difference there due to the voltage drop in my battery load tester, so I'd stick with the 145 watts here because that probably has way less voltage drop than my battery load tester has. Now, testing the 5521 connections, I was able to pull around 5 amps or around 65 watts out of those before it shut off from being overloaded. Now, of course, I want to test both at the same time, so I plugged in both battery load testers, and I was able to pull around 180 watts without this shutting off. Now, anytime I went over 180 watts, it would shut off after about 2 minutes or so from just being overloaded. So don't plan on more than 180 watts, which is still pretty decent for this size of power station. Now, if you've seen any of my other videos in the past, you sometimes have some weird bugs with USB ports, so it's important to test those out. So I plugged in a ton of different devices into the front of the power station. I had 2 power stations charging off of the USB-C outputs, one at 100 and one at 60 watts. I had 2 phones plugged in. One was charging off the Quick Charge 3.0 port, and one was charging off the last USB-C port. I had a USB fan plugged in and a USB LED light. And all that combined together was pulling around 180 watts, so very impressive outputs. I also wanted to test running the DC output at the same time as the USB ports just to make sure they would both work. And I was pulling a total of 300 watts out of the front of this power station. So this power station is very capable of charging all your mobile devices or DC gadgets at the same time. Now, I did 2 final tests on the DC output. One of them was to test to see if it had any auto shut-off settings, so I plugged in my 12 volt compressor fridge, let it run for 30 hours. Well, it came back and everything was still running. So no auto shut off settings on the DC output. The final test was a full capacity test, meaning I took it from 100% all the way down until it shut off using the DC output, just so we could compare it to the advertised capacity. Now this is advertised to have 1,536 watt hours, but what do you actually get after efficiency losses and after conversion from 48 volts down to 12 volts? So I plugged in my battery load tester and I discharged it at 10 amps all the way until it shut off, and I was able to get 1,253 watt hours, or around 81.5%. So we didn't get quite 85% on this. This is pretty normal with larger power stations because of the conversion losses, and you usually see more capacity as you use the AC inverter. Okay, so I've gone ahead and flipped the power station around so you guys can see the back, because I want to talk about the AC inverter. So there are 4 15 amp outlets on the back where you plug in your appliances, and the AC inverter on this power station is rated at 1,500 watts continuous or 3,000 watts surge. It's also advertised to have a pure sine wave output at 60 hertz and a voltage of around 110 volts. Now, of course, I did testing on the AC inverter, so let's go ahead and jump into those results. Now, the first test that I put on the AC inverter was a max load test of 1,500 watts for 15 minutes to see if it could handle it without any issues. So during that test, I plugged in my oscilloscope, and yes, it was putting out a pure sine wave at 60 hertz. It was putting out 111 volts, so even under max load, you still get good power output. Now, at about the 8-minute mark, the fans were kicked on as high as they go, and this is what it sounded like with those fans running. So you can see it's right around 55 decibels, which I'd say is pretty average for this size of a power station. It wasn't too loud or wasn't any quieter than what I've seen in the past. Now, one thing that did concern me was the actual temperature sensor in this power station was kind of going up pretty high on the battery temperature. So let me go ahead and show you what I filmed during that test so you guys can see what was happening. Okay guys, just wanted to check in on the power station. It's been going for 12 minutes, almost 13 minutes. Now we can actually see the specifications of what's going on. If we click the info button and then BMS status, we can see the internal temperature of the battery. Now I'm not sure where this battery temperature sensor is, but you can see it's reading 149 degrees Fahrenheit. So maybe this is on some sort of bus bar and it's just getting a little bit warm there. I doubt that the batteries are actually this warm. You can see it just hit 150. Now just to follow up with that, the air coming out of the power station is actually not that warm. So I'm kind of curious if it's just an inaccurate reading or just a weird placement for the temperature sensor. Okay, so I just wanted to run the test a little bit longer than normal just to see what would happen, because that battery temperature sensor, you see we're running at almost 17.5 minutes, still pulling 1,495 watts. We're not getting any voltage drop, still getting a pure sine wave output. Let's see what the temperature is. Okay, so we're sitting at 156 degrees on the battery temperature. So I do think this is maybe a bus bar temperature measurement. So I don't think there's an actual issue with this high temperature, but they probably want to update at least where this is reading, because this would be alarming to some people if they saw their temperature at 156 degrees. Okay, so I turned off the AC inverter and the fans are still running to cool off the power station. This is normal for any power station that has a max load test, but you can see the temperature is actually dropping down fairly quickly. So yeah, I'm not too worried. I don't think it's the actual batteries inside the power station, but probably a bus bar measurement. And yeah, you can see it's already down from 150 plus down to 132 in less than 5 minutes after turning off the AC inverter. Now there are a few other tests that I like to run on the AC inverter just to make sure that all your electronics are going to be compatible. Now one of those is to test to see if this has any noise. So a good way to test that is by plugging in a guitar amp just to see if it sounds weird when you turn on the guitar amp running off the AC inverter. So when I plugged in my guitar amp, I compared the inverter power versus my wall power, and this is what those sounded like back to back. And as you can see, you can't really tell any difference between this inverter and wall power, so I'd say that's definitely a pass. Now the next thing I like to test is a parasitic drain on the AC inverter, because usually if you leave it on over a given amount of time, it's going to burn background power of the battery itself. And some power stations have huge parasitic drain. They'll have around 2% per hour. So I tested this one. I left it for 3 hours, and after 3 hours it was sitting at 97%. So it's around 1% per hour, which is acceptable for this size of a power station. So if you do leave the AC inverter on with no load, just expect around 1% loss per hour. Now the inverter on this power station actually supports UPS functionality, which means it's an uninterrupted power supply. So when you have this charging off the wall or plugged into the wall, it actually passes the power straight through to your appliances outside and it doesn't touch the batteries. But when the power goes out or you unplug it from the wall, it will swap over to the battery backup within 30 milliseconds. So a lot of new power stations are picking up this capability. It's very nice to have this if you want to plug this in, in line with your computer or desktop, and your power goes out, it'll keep your computer running. Now it's important to know if this swaps over fairly quickly. So what I did is I plugged in my studio lights and unplugged this, and you can see the fastest flicker on the screen. Now you have to watch very carefully, but you'll see it flicker and then it already goes over to the battery backup. And you can see that the voltage changes as it does that because my wall power is right around 120 to 119. And when it swaps over to the backup batteries and the inverter of the power station goes down to around 111 volts. So it does drop over to the battery backup fairly quickly, and I don't think that's an issue for most electronics. Now there will be some sensitive electronics that's not fast enough for, so it's not meant to replace a high-end UPS backup, but if you had your fridge plugged into this or whatever, it would be just fine running your fridge in a power outage. Now the last test that I like to do on the AC inverter is a complete discharge test. So after having it charged up to 100%, I discharged it using the AC inverter at a 0.2C discharge rate, which takes around 5 hours or so. And the results of that test were 1,320 watt hours. So if we compare that to the advertised capacity of 1,536, we do the math, that's 85.9%. So we did hit our goal of 85% of the capacity. So if you use the AC inverter all the way down until it shuts off, you should expect around 1,320 watt hours. Now in the next section of the video, I want to talk about charging up this power station. There are 4 different charging ports on the back of this. Now it's very simple. Let's go ahead and take a closer look. So the first charging port is for AC input, meaning you can charge this off just your wall outlet or a generator. You do not have any external charging bricks, which is completely awesome. You just have to bring this and the charging cable and it's good to go. So you can plug in your AC charging cable here and get around 550 watts of charging input, which means you can charge this in less than 3 hours. Now I did notice with my oscilloscope there is just a little bit of distortion on the sine wave whenever it's charging, so just be aware of that. The next charging port is for solar panels. It's an XT60 male connection. It supports 15 volts up to 58 volts at 10 amps, meaning you can connect 2 12-volt solar panels together in series on this power station. Now the next port is a 6530 port. It's designed for car charging. This comes with a car charging cable. You plug it into your vehicle, your boat, whatever, and it'll charge at around 125 watts using 12 volts. Now the next one seems to be tied to that. It's just another input. It's the Anderson power pole input, but I tested 24 volts on that and I was able to charge at around 250 watts. So many different ways to charge this up. Now this also does support pass-through charging. You can charge it and use it at the same time. It'll both charge the battery and pass power out to the devices, so very cool there. Now of course I did solar testing on this power station. Let me go ahead and show you the footage that I did while I was testing it out with multiple solar panels.
Okay, so I want to go ahead and test the charging capability of this power station. Now these are my BougeRV 180 watt solar panels and they're usually connected all together in series for my larger power stations. But right now I only have these 2 that are going into the power station, so let me show you how that works. Okay, so I have it here sitting in the shade of the solar panels and I have these 2 panels connected together in series and plugged into the back of the power station. Okay, so with the 2 solar panels connected, we're getting 32.1 volts, 7.8 amps, right around 250 watts. Now in order to get more power into the power station, just to see what the maximum solar input is, I've actually connected 2 of these together in series and then 2 of these together in series, and then those are connected together in parallel. So the voltage is fine and we've doubled the amperage. Let's go ahead and see what we're getting now. Okay, so with all those connected together, we're getting 38 volts at 10 amps, right around 376 watts. So it does appear to have a 10 amp input limit. Now the solar conditions are pretty good today. It's right around 95 degrees, so these panels are pretty warm.
Now I thought it'd be helpful to show you the size comparison between a few power stations that I have. The far left is the Bluetti AC200P and the far right is the FF Power P2001 with the LemiPower in the middle. Now when you compare all three models together, the LemiPower is definitely the most portable out of all three, and it still offers a good amount of power output. Now speaking about the actual weight of this power station, it comes in at 42 pounds or 19.5 kilograms, and you do have a little extra weight because the battery chemistry inside is lithium iron phosphate, so you get a lot of charge cycles in exchange for weight. This also is very safe. It doesn't have any fire risk like you'd see with another power station with lithium ion or NMC batteries. Now this also has some other cool features like the handles on top. They are retractable and they kind of stay down, so you can stack things on top, so that's nice there. There's also wireless charging for your cell phone on top. It is a 15-watt wireless charger, so you can put your phone on there and it'll charge it up without any issues. You just have to make sure the DC output is enabled. Now on the front and back, you have adjustable light bars that are LED. You can either turn the brightness all the way up or turn it all the way down. You can turn them on and off with the buttons on it or with the smart app. Now I wanted to take a second to talk about the screen on this power station. I really like how big it is. It's very bright and it's easy to read. Now on this side, you have your wattage input whenever it's charging. And then on this side, you have your wattage output. Now what's really cool is you can click these and it'll tell you how long it's going to take to charge till full. And then this side, it'll tell you how long it's going to take until it's empty. So you can have those estimated numbers there. Now in the middle, you have a large battery percentage with this ring that kind of goes down to tell you, when it's empty, and it tells you if it's charging or discharging. Now this power station always sits on 99%. It rarely sits on 100%, so just keep that in mind. You have the ability to turn on the AC inverter, the DC output, the USB ports, and the screen right here. And then you also have the ability to turn on and off the LED light bars. What's really cool is you can also adjust the brightness for these LEDs. I'll show you that here in a second. Now looking at the settings for the power station, you can change the language, you can set the beep to silent. You can see it's set to silent, but it's still beeping. You can also change the temperature to Fahrenheit or Celsius. Now remote control is how you connect to it with the app. You have Bluetooth connection or a Wi-Fi connection. And I currently have the Android app installed on my phone, and it works very similar to the settings that I'm showing you here. So you basically have a mirror of the settings and the inputs and outputs on the app itself. So it's pretty cool that this has the smart app. Now going on to the next screen, you can actually set the standby time, which seems to be in eco mode, where basically if it doesn't sense anything coming out or in, it'll shut it off automatically. You can set that anywhere from 30 minutes all the way up to always on, and I have it set to always on. The auto backlight is when it shuts off the screen. You can set that to 10 seconds or always on. And this is where you change the LED brightness on the light bars. So pretty cool that you can adjust that. And you can set the time and date. And then you can reset the factory settings. If you want to go back to the home screen, you just push that here. Now, there's another button where you can push to get more info. Now right here you can get the device info, kind of the serial number, firmware version, and if you click tech support, I'm guessing they'll eventually have a QR code here that you could scan with your smartphone to get the actual contact information, because if you click contact us, nothing comes up. You can see all the power coming in, the volts, amps, and wattage, which is really cool, and that's for the input. You can click on the output and you can also see all the power going out through the AC inverter, DC output, USB ports, and wireless charging. With the BMS status, you can see the state of charge of the battery, the actual battery voltage, which is pretty cool, and the battery current coming out. And you can see the battery temperature. And then what's really cool is you can click on the battery cells and you can see each individual voltage for all the cells connected together in series. This is a 16S battery with 30 amp hours in each battery, so lots of power available in this. Now, if you guys haven't seen my power station reviews in the past, I like to put these through my power station grading sheet, and I give them a score of 1 to 10 so you guys can compare how these perform against the competition, especially where price and features are involved. So let's go ahead and fly through these really quick. Each one is for a point. So does this charge in less than 4 hours? Yes, it does. Does it accept pass-through charging? It does. Does it have a pure sine wave inverter? It does. Regulated output? It does. Informational display is great. Auto shutoff settings, there are none. USB-C, it does support 100 watts, but it's not bidirectional, so I'll reduce a little bit of the points there. It does meet 85% of the advertised capacity, and it does charge within 5 hours with solar panels. Now, the one thing that it does have an issue with is the price per watt hour. The MSRP is about around $2 a watt hour, when I like to see around 80 cents or less. Now, most big brand name power stations come in right around $1 per watt hour or a little higher, and you usually pay for those really good features. Now with this having a lot of those features, you would expect somewhere around $1 a watt hour, maybe a little bit more, but not $2 a watt hour. So I cannot give it a point there. Just be aware that the early bird pricing at $1,400 is the best price that you can get this at, but the next one up, $1,600, is a little bit more than $1 per watt hour. So you do have some other options on the market for a cheaper price. So you'd have to compare to see which one works better for your use case. Okay, so we're coming to the end of the video, and I thought I'd give you guys a few final thoughts about the LemiPower 1500. Now before we jump into maybe some pros and cons, I did look on the bottom of this, and there actually is a UL listing on this. So this is the first power station that's actually UL listed that I've tested on the channel. So thumbs up to LemiPower on that. I know that's a pretty tough certification to get on a product. So, you know, EcoFlow and Blue Eddy don't even have UL listed products. So very cool that this one actually has the UL listing certification. So let's talk a little bit about pros and cons. So if you're looking for something that has a lot of features, high quality, performs very well, is somewhat portable, then this is going to be a great power station. Didn't see really any issues with it. It definitely performed as advertised. But then we look at some of the cons. For example, this doesn't have expandability. Would have been really nice to see expansion batteries for this. And the price is a bit high for what you get. Now you have to remember, this is actually a Kickstarter product. So it's an unfinished product. It's not completely polished. There may be some other bugs that I haven't found. One of the cons would be it's got a pretty high price tag for being a Kickstarter product. I would love to see just maybe $100 off the early bird price and then $100 off the regular Kickstarter price. That would have brought it down to more of a reasonable level with the feature set. And the MSRP of $29.99, that's just kind of that's just way too expensive in my opinion. If this ever sells for $29.99, just go find something else. That's just way too expensive. But if you're gonna look at picking this up during the Kickstarter, you still have quite a good discount on it, and it was a very good performing power station. So hopefully after watching this full testing and review video, you guys can kind of make the decision on if this one is right for you or not. You know, I can't give you guys that decision because each of you guys have a different use case. So you'll have to kind of see how this performed, and then maybe look at all the other power stations that I've tested on my power station grading sheet and determine, is this a good option or is something else a better option for you. Now I will continue to give an update on this, especially when it actually goes and launches as a full product that's not on the Kickstarter campaign. Very impressed with LemiPower. It's good to have a new face on the market with all these features, and I expect a lot from this company in the future. So thumbs up LemiPower. If you guys have any questions or comments or feedback about this power station, throw a comment down below. I'd love to hear what you guys think about it. And I appreciate you guys watching to the end of the video. Please give me a thumbs up if you like the review. Also, if you guys like this type of content, I would invite you guys to subscribe to the channel. We always talk about power stations, batteries, solar panels, and basically everything that has to do with that. Anyway, thank you for watching. We'll see you guys next time.